Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at lesson 7.2.5. We are now going to start taking what we know about equations and slope ratios and y-intercepts and all, and sort of blend it in with what we learned all last year about proportions and proportional reasoning, and we are going to create proportional equations. So, first of all, the constant of proportionality. That's a term that's kind of important here. The constant of proportionality is the slope ratio. Highlight that, the slope ratio of the proportional situation. So if we've got the rule that says y equals mx plus b, where m is the slope ratio or the growth rate of a situation and b is your y-intercept, let me go ahead and write y-intercept in there. Then when we have a proportional type of a situation, you may recall the two things that were always true with proportions. First of all, there was a constant growth rate, and secondly, 0, 0 applied, which means that the y-intercept would have to be 0. So we often see a proportional equation in the form of y equals kx. Notice that there's no y-intercept here. That's because b, in this case, is equal to 0, and k is taking the place of m for our slope ratio, and they are the same thing, right? Right there, that's a growth rate, that's a growth rate. So m is the slope, k is the slope. They often call, in a proportional situation, the slope the constant of proportionality. Okay, and I think that's why it's a k instead of an m. But if it makes it easier for you to think of it as an m, because that's what we've been working on this entire time, let's go ahead and think of it as an m. It doesn't really make any difference. The slope ratio of a proportional situation is the constant of proportionality. All right, so in chapter 1, you identified proportional relationships in both tables and graphs. Today, you will look at the connection between slope and graphs of a proportional relationship. So Mr. Mears was running for mayor of Atlanta. His campaign managers were eager to determine how many citizens of Atlanta would vote for him in the upcoming election. They decided to pay a respected, impartial statistical company to survey potential voters, right? So this is a process that we refer to as polling. And you may recall last year we were talking about different ways that you could get fair data, what do we call it, representative samples and whatnot, as it was related to probability, right? And so that's kind of what's happening here. So they are going to find a company that's going to do the polling to find out how many people would probably vote for Mr. Mears, because as you know, when you do this polling, it's all based on proportional reasoning, and we think the theoretical probability is going to come close to matching the experimental probability. Well, this is an example of like experimental probability. Okay, so one afternoon, pollsters called 100 random potential voters in Atlanta to ask them how they would vote. And during that survey, 68 out of the 100 people indicated that they would indeed vote for Mr. Mears. So it's like 68% of the people are saying that they would vote for Mears for mayor. Okay, so if the pollsters had instead called 50 people, not 100, how many would have said they would vote for Mr. Mears? So remember, this is our probability, and we can set it up proportionally to solve for x here, because that's what we learned last year, right? And here the question, do you suppose this is proportional? Yeah, it is proportional. Basically, if nobody votes at all, nobody would vote for Mr. Mears. And yeah, so that's where the 0, 0 comes in. And just the fact that, you have a constant multiplier happening here. So 50 people are called, and you end up with, does everyone know what the answer is now? It's 34 voters, right? 50 times 2 is 100, so 34 times 2 would be 68. Or 100 times 1/2 is 50, so 68 times 1/2 will tell you how many of these voters are likely to vote for Mr. Mears, right? 68% of the total would vote for Mr. Mears, and 68% of 50 is 34. So Karina's neighborhood has 327 potential voters. If voting in her neighborhood is similar to that of the poll, how many neighbors will probably vote for Mr. Mears? So I'd like for you to pause the video, copy down this table at the right, and then use your proportional reasoning to solve for X. Go ahead and pause until you get that done, and then unpause so you can see the reveal. All right, so we know that 34 people out of 50 would vote for him, and 68 people out of 100 would vote for him. So how many out of 327 would be likely to vote for him? So you can set up the ratios, and you can use your proportional reasoning. Are you going to say that 100 times 3.27 gives you 68? You could. No. If 100 times 3.27 gives you 327, then 68 times 3.27, that's what I'm trying to say, would give you your number of voters that would vote for Mr. Mears. That's one way of doing it, but my preferred method has always been to cross multiply. So if we take 68 times 327, you get 22,236, and then 100 times x, that gives you 100x. Then you divide each side by 100 using your calculator, and what do you end up getting for your answer? You should have gotten about 222 people, right? Or more specifically, I guess we could say that x is equal to 222.36, but there's no such thing as 0.36 people, so we'll just go with the 222 as our answer. So make a graph of the data that Karina has collected and draw a line through the points. Should your line go through the origin? I think you already know the answer to that, right? It's a proportional situation, so 0, 0 absolutely applies. Oops, I never covered that up. I guess you got the answer there. Yes, it's a situational, proportional situation, so it would pass through the origin. So let's go ahead and take that data, set up this as your graph, where the number of potential voters is your independent variable, and the number of people that vote for Mr. Mears would be dependent, okay? That's important to understand which one is X and which one is Y here. How many people are going to vote for Mr. Mears? Well, it depends. How many total voters are we talking about? Because he's going to get 68% of the vote. So your independent variable is your potential voters, and the vote for Mr. Mears goes here. So go ahead and complete this graph, and then take the information from here, where it turns out this is your X and this is your Y. That's your independent variable. This is your dependent variable. And then plot these points and then connect the dots. And unpause when you are ready to see the reveal. All right, here's our graph. So what are the points that we've got? We know we've got 0. No, yeah, we got 0, 0. We got 50, 34. I don't know why that's there. That shouldn't be there. This guy should be moved up a little bit. Stop it. Let me take this, group those guys together, move them up to here. Yeah, those are supposed to be going right there. Okay, so this point right there is where X is equal to 50 and Y is equal to 34. This point right here is where X is equal to 100 and Y is equal to 68. And this point here is where X, stop it, where X is equal to 327, or approximately there. Y would be equal to about 222. So now it says, or now we have to figure out what is the equation for the situation. You can already see it there. I forgot to cover it up. I'm so sorry. But how do we get the slope? We know how we get the y-intercept because it's a proportional situation, and the y-intercept is equal to 0. So if we use the y equals kx or the y equals mx method, we will figure out the slope of this line by taking any 2 points, right? We could take these 2 points. We could take 168 and 327, 22, or what I think would be best to do is to just take the 0, 0 and any of these other points, doesn't matter which one you do, and figure out what the rise over the run is, the change in x or the change in y over the change in x. And so this is how that would look. If I chose these 2 points to do, the change in y is equal to 34, right? To go from 34 to 68, and the change in x is 50 to go from 50 to 100. If I chose 0, 0, and 50, 34, you'd get the exact same thing, right? Y value increases by 34, and the x value increases by 50. So if you want to write this where the slope ratio is 17 over 25, you could do that. I would just prefer to use a decimal number rather than use a fraction, but there's no reason why you couldn't have said y is equal to 17 over 25 as your slope ratio or your constant of proportionality, and then whatever x is, you multiply it times that fraction. Okay, I think since you're using calculators, probably we'll just go with that rule. That includes a decimal variation of your slope ratio. So now it says, use the equation to help Karina figure out how many people will probably vote for Mr. Mears if Atlanta has a population that allows for 350,125 voters. Okay, what do the x and the y represent in this situation? Well, x is your independent variable, right? So that would be the total number of potential voters. And y is your dependent variable, so that's going to be the number of people who vote for Mr. Mears. So when we plug in x, we're going to plug it in here, and we're going to take 0.68 times 350,125, and what we get for our answer is the number of people that we expect to vote for Mr. Mears. Okay, I never really wrote that down, but you got the answer. What do x and the y represent? We already talked about that. All right, so now what information would the unit rate give Karina? What is the unit rate of this particular situation, and how does the unit rate compare to the slope? Well, the unit rate is what you get when you say for every voter, how many of those voters would vote for Mr. Mears? And so what we end up seeing here is your unit rate in this situation is the slope ratio. They're the same thing. And so in these particular problems, your constant of proportionality, the slope of your line, your growth rate, all of these are really synonymous with unit rate. 0.68 votes for Mr. Mears for every voter, but for me, it just seems like it's more logical to do that as a percent. 68 out of 100 voters, or 34 out of 50 voters, but easier this way, 68 out of 100 voters are going to vote for Mr. Mears. All right, now let's look at a different situation. In 2 minutes, Stacy can write her name 17 times. Okay, so here's the ratio to express that. 17 times that she writes her name for every 2 minutes. Use a proportion to find out how long it will take her to write her name 85 times. Okay, go ahead and solve this right now and unpause when you are ready to get to that answer. Are you ready? Did you pause? Did you figure out that your giant one here, what do you multiply times 17 to give you 85? That would be 5. So if we multiply 2 times 5, you would get an answer of, it'll take you 10 minutes for her to do that, assuming she doesn't get bored and just quit before then, because who really wants to write their name nonstop for 10 minutes, right? So make a graph of this situation. Which piece of information is on the dependent axis? All right, this is the part that's a little tricky. And I'm going to tell you, sometimes it doesn't really make a whole lot of difference which goes on the x-axis and which goes on the y-axis. And just for clarification, the dependent axis is the y-axis, okay? The independent axis, the independent variable is always the x variable. So which one goes? I know we wrote the x here that corresponds with the 2, but I could have just as easily inverted it and put the 2 on the top and the 17 on the bottom, and I could have used a different variable. So I don't want you to think that just because I randomly chose an x here to go with the 2, that means that time is the independent variable and the number of times she writes is the dependent variable. But it turns out that's exactly the case, okay? So what we're trying to ask is this. how many times can she write her name in 10 minutes or in 2 minutes or per minute? So what we are controlling here is the time, and we're trying to see what effect that has on how many times she writes her name. Okay? Another way of saying it is this. How many times did she write her name? And your question then is, well, that depends on how long you gave her to write it. So the number of times that she writes her name depends on the amount of time that you're talking about, on the number of minutes. So in this case, the number of times that she writes her name is the dependent variable. And the independent variable would be the time in this particular situation. So another name for the slope, we've already talked about this, is constant of variation. Find the constant of proportionality. No, did I say constant of variation? I mean the constant of proportionality. It used to be called a constant of variation when we called this kind of a situation direct variation, but we're not calling it that anymore. So we'll call it constant of proportionality. Find the constant of proportionality and write an equation in y equals mx plus b form for species situation. What do the x and the y represent? Okay, so find the unit rate or the constant of proportionality. Let's rewrite the situation where we take 17 over 2, and now let's write it as x over 1. Okay, so what is your constant of proportionality? What is your unit rate for this particular situation? Go ahead and see if you can figure that out, and unpause when you're ready for the reveal. Okay, so remember, to find a unit rate, there was a shortcut. The shortcut is if you just take this ratio that's been provided and do the division, right? 2 divided by 2 is 1, so we have to take 17 divided by 2 to find out our unit rate. You just take these two numbers and do the division. And when you do that, you get an answer of 8.5, which means that your constant of proportionality or your unit rate or your slope for the situation, all meaning the same thing, is 8.5. Okay, so what do the x and the y represent in this situation? Well, x is the independent variable. We said that was going to refer to the number of minutes that she is spending writing her name. And y is the dependent variable. So y represents the number of times that she is writing her name for x number of minutes. So it says here that she can write her name 8.5 times per minute. So if it's going to be 10 minutes, 8.5 times 10 would give you 85, correct? And that's what we set up here. So use the equation to find out how many minutes it will take Stacy to write her name 85 times. So in this case, 85 times, the number of times she's writing her name goes in place of the y, and we will solve for x by taking 85 and divide it by 8.5 to get what x is, and x ends up being equal to 10. And then, of course, check it by saying 10 times 8.5 is 85. Yes, it is. We know we've got it correct. Okay. So what is the advantage of the equation in part D compared to solving proportional reasoning? And I'll be honest with you, I don't know what the advantage is. You know, I mean, I think both of them are relatively easy. If you know the value for y, you just divide and get your answer for x here. And if you know the value for x, you just multiply and get your value for y. But then, you know, when you set up the proportion, it's so easy to look for giant ones or cross multiply. So I don't really think it comes down to anything other than your preference. Some people, in fact, I think CPM wants you to say that using the rule or the equation is better, but I don't think one way is better for everyone. You just have to decide which works best for you. So remember, we are talking about unit rates are the same as slopes, and constant of proportionalities and constants of variations, if you will. Go back in time a little bit, use a previous term. So the unit rate is the same as all the others. The unit rate is 8.5 times she writes her name per minute. And there is the graph for this particular situation. Notice that it passes through 0, 0. Notice that it passes through 217, and it passes through 1085. So this point right there has to be the unit rate. When x is equal to 1, y is going to be your constant of proportionality or your unit rate for this proportional equations graph. All right, Beth and her father have a large model railroad in their basement. Beth figured out that the equation y equals 260 over 3 times x relates the length of an item on her model railroad to the length of the real thing, where x, let's go ahead and highlight this, x is the size of the model and y is the real object size, okay? So that's important for us to understand. That means that x in this case, the size of the model will be our independent variable. And so when we create a graph for this situation, we'll want to have the model sizes on the x-axis and the real objects, the actual size, on the y-axis. And so we'll probably be given values for x and try and find the corresponding real measurements for y. Okay, so Beth has a different model railroad in his home. It has a different scale. He put together the following table for Beth. Okay, so this applies to Beth's uncle right here. So it looks like the real object in real life would be 60 inches. It's only, it's a little bit less than an inch here, right? And a tree that is 3 inches, 300 inches in real life is 4.7 inches on his model. And an apartment building, which is 480 inches in real life, I wish they would give that in feet, but we're sticking to inches, would be 7.52 inches in the model. Okay, so since this relates Beth's situation, I'm guessing that our constant of proportionality or our slope ratio for this situation is going to be a little bit different. So it says in decimal notation, what is the unit rate for Beth's railroad and for her uncle's railroad? Okay, so I've revealed everything. You can just copy it down. We need to find unit rates. And so to find the unit rate, you do the division. What is 260 divided by 3? You take your calculator, 260, and you divide it by 3, and you get a unit rate of 86.6 repeated, or 86.7 inches in real life represents 1 inch on the model. And now for the uncle, I just decided I would take this one right here. Let's take those two, but you could have taken these two numbers or those two numbers as well. I don't know why. I guess I just decided to go with 3, just look like some easy numbers. So what is 300 divided by 4.7? To find the unit rate for this situation, 300 divided by 4.7, you get 6.3829. I rounded that to 6.38. So in real life, for every 1 inch on the model, that's 63.8 inches in real life. Okay, so these are different unit rates. Looks like Beth's model has the greater unit rate per inch than the her uncle's model. So, yeah, I guess we're done with that. So basically, this is just another way of looking at a situation. To find unit rate, you do the division, right? This divided by that gives you the unit rate. This divided by that gives you the unit rate. And so in this case, I don't really like this problem very much because I don't like the fact that our unit rate is inches per inch. It just seems weird, but that's what it is. Let's move on. All right, 8 out of 29 students in your class want to attend the Winter Ball. Find the constant of proportionality and then write an equation for the situation and identify what do the x and the y represent in this situation. And then if your class represents the entire school, that is, this is like a representative sample with similar ratios for every other class throughout the school. If we think that this is a good representative sample and that this ratio applies to the entire school, then how many of the 14,900 students will probably go to this dance? Okay. So go ahead and pause and record this information here and answer parts A and B and see if we get the same answer. All right, so what do we got going on here? If you want to find the unit rate, then go ahead and do the division. If you want to change this slope ratio into decimal form, go ahead and do the division and write it as a decimal number. Now this divided by 29, gives you a repeating decimal, so I just rounded it off. You could have rounded it off maybe to 2.8, but that is so close, right? So I decided to call it the 0.276. So if you're going to write that as a equation, you could write it using the ratio, which would actually give you the most accurate answers if you just kept it as a fraction, because when you change it to the decimal number, you end up having to round it, and this is going to sacrifice a little bit of accuracy by rounding it up. Okay, this one is exact. When you get this answer, then your final round will be the most exact answer you can get. And what do X and what does X represent here, and what does Y represent? Well, how many students are going to be attending the ball? It depends. How many total people are in the school? How many people are we talking about? So the X is going to represent the total student population, because only 27.6% of the students are going to go to the dance. So you'd multiply this times the total, and Y is going to represent how many people attend the dance. So now let's solve given this problem. So we're going to multiply this fraction or this decimal number times the total, and that's going to give us how many people we expect to go to the dance. So go ahead and look over your work. I'm going to reveal in a second. Make sure you got your answer. Okay, so let's start here. If we take this particular equation for this situation, we plug in the total number of students, and you multiply 0.276 times 1490, you get about 411 students. Let's double check that. 1490 times the rounded off version of this unit rate, which is 0.276, and you get 411.24, which would round to 411 students. Okay? If you chose to use the fractional version of this, you would have to multiply 8 times 1490, right? Numerator times numerator and denominator times denominator. So multiply 8 times 1490, and whatever that answer is, you then divide it by 29, and let's see what we get. 8 times 1490 is 11,920. So it becomes 11,000, what was that again? 920 over 29. So now let's do the division. Take that number, divide it by 29, and we get pretty much the same answer. It's a slightly different decimal portion of it, but it's still about 411. Okay, so notice that the decimal answer before was like 0.24 or something like that there. That's because we rounded this up. So all of our answers with the decimal variation of our slope ratio or of our constant proportionality or of our unit rate, whatever you want to call it, this is going to be a little bit more than the actual answer. But in this case, it ended up not really affecting it because both of those answers rounded off to 411 students. Okay, so now we're going to include proportional equations into our problem solving, and these proportional equations end up taking the same form as y equals mx plus b, with the exception that with proportions, there is no y-intercept in our equation because it's always equal to 0. So we're not going to add 0 to anything. We're just going to leave it like that. Alrighty, let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.